start with the basics. What exactly is an operating system, or OS? Think of it as the invisible manager that sits between your computer's hardware, like the CPU, RAM, and disk, and the apps you use every day. Whether you're on Windows, macOS, Linux, Android, or iOS, the OS is the software that makes everything work together smoothly. Without it, your computer would just be a pile of electronic parts with no intelligence. The OS handles all the complex details, so you can open apps, browse the web, or play games without worrying about how it all happens. Imagine a hotel with many rooms, a kitchen, and lots of guests. If every guest tried to use the kitchen or pick any room they wanted, chaos would follow. That's why hotels have managers who decide who gets which room and when the kitchen is used. The OS acts just like that manager for your computer, organizing resources so every app gets what it needs, safely and efficiently. Without an OS, every program would have to handle hardware directly, making things extremely complicated. Before we dive deeper into how the OS works, let's quickly meet the main parts of your computer's hardware. There's the CPU, often called the brain, which processes instructions. RAM is fast, temporary memory for running programs. Storage, like your hard drive or SSD, keeps files and the OS itself safe even when the power is off. And then there are input-output devices, keyboards, mice, screens, and network cards that help your computer interact with the outside world. The OS coordinates all these parts, making sure they work together. Every operating system, whether it's Windows or Linux, has 5 main jobs: managing processes, managing memory, organizing files, handling devices, and ensuring security and user interface. These core responsibilities are what keep your computer running smoothly, no matter how many apps you have open or what you're trying to do. The rest of our explanation will break down each of these areas in detail, so you'll see exactly how the OS keeps everything under control. So what happens when you press the power button? At first, your computer's memory is empty and the OS isn't loaded yet. The boot process begins with a tiny program called BIOS or UEFI, which checks if the hardware is working. Then, it finds the right disk and loads a small program called the bootloader. The bootloader's only job is to load the OS kernel into memory and hand over control. The kernel then wakes up, detects hardware, loads drivers, and sets up memory and process management. Finally, you see the login screen. Your OS is ready to go. The heart of every OS is the kernel, the core part that talks directly to hardware. For safety, your computer's memory is split into 2 spaces: kernel space and user space. Apps run in user space and can't touch hardware directly. Instead, they make requests called system calls to the kernel, which checks and carries out the request. Think of it like a bank. Customers' apps ask the teller kernel to access the vault hardware, but never go in themselves. This separation keeps your system safe and stable. Ever wondered how you can run a browser, music player, and text editor all at once? That's process management in action. When you start a program, the OS loads it into RAM and marks it as a process with its own memory and ID. The CPU can only do one thing at a time, but the OS rapidly switches between processes, giving each a tiny slice of time. This happens so fast, it feels like everything is running simultaneously. The OS uses a scheduler to decide which process gets the CPU next, using strategies like first-come, first-serve, round-robin, or priority-based scheduling. Each process goes through several states: new, just created; ready, waiting for CPU time; running, currently executing; waiting, paused for input or data; and terminated, finished. The OS keeps track of all this, so when the CPU switches from one process to another, it can pick up exactly where it left off. This switching is called context switching, and it's what makes multitasking possible, even on a single-core CPU. RAM is limited, but you often run many apps at once. The OS uses clever tricks to make it seem like each app has its own huge memory space. This is called virtual memory. The OS maps each app's virtual addresses to real spots in RAM, keeping everything separate and safe. If RAM fills up, the OS temporarily moves less used data to the hard drive, a process called swapping. This can slow things down, but it prevents crashes when memory runs low. Manage memory. The OS divides RAM into small blocks called pages. Each app's data can be spread across different pages, and the OS keeps a table to track where everything is. When RAM is full, the OS swaps out less used pages to disk, making room for new data. If both RAM and swap space run out, you'll see an out-of-memory error. This system lets many programs run smoothly, even with limited physical memory. A hard drive or SSD is just a huge collection of tiny spaces. The OS's file system organizes these into files and folders, making it easy for you to find and use your data. Each file has a record with its name, size, permissions, and where its data is stored. Big files can be split into pieces and scattered across the disk, but the OS puts them back together for you. Folders are special files that list other files and folders, creating a tree-like structure. The OS controls who can read, write, or run each file. This is the foundation of security in multi-user systems. Modern file systems also use journaling, which means they log changes before making them. If your computer loses power suddenly, the OS can recover and avoid data loss. These features keep your files safe and your system reliable, even when things go wrong. Free hardware device, printers, keyboards, graphics cards works differently. The OS uses small programs called drivers to communicate with each device. Instead of constantly checking if a device needs attention, devices send signals called interrupts, like ringing a doorbell. The CPU pauses its current work, handles the interrupt, and then goes back to what it was doing. This system keeps everything running efficiently without wasting time. Let's put it all together. When you double-click a browser icon, your mouse sends an interrupt. The OS's kernel catches it and tells the desktop environment. The desktop asks the kernel to start a new process for the browser. The OS loads the browser from disk into RAM, adds it to the scheduler, and gives it CPU time. If the browser needs to load a web page, it asks the kernel to use the network card. The OS manages all these steps in fractions of a second, making everything feel seamless. There are many operating systems, each designed for different needs. Windows is common for personal computers and gaming. Linux is open source and flexible, used in servers and by developers. macOS is Apple's Unix-based system for their computers. Android and iOS power most smartphones and tablets. While their designs differ, they all share the same core responsibilities: managing processes, memory, files, devices, and security. Sum up, the operating system is the ultimate manager, sitting between hardware and apps, making sure everything runs smoothly. The kernel is the core, handling direct hardware control. Multitasking is an illusion created by fast context switching. File systems organize data, virtual memory keeps apps running, and interrupts make device handling efficient. Understanding the OS helps you appreciate how your computer juggles endless demands with limited resources.